Henry. Similarly, I am going to check it here. Okay. So first one is 9 divided by 70. Okay, so I am writing here 9 divided by 70. Similarly, second one I am going to find it out. Okay, so I am use it here. What is the word? Sentence, do I like Henry? So $yes, do I like Henry? End of the sentence. Okay, so for this I am going to predict it. Okay, so if you do the same thing, okay, so how we can find it out? Probability of the entire sentence will be splitted into individual probability, that is probability of do if the given is starting of the sentence. Similarly, probability of I given is do. Okay, then probability of like, the given word is I, into probability of Henry, given word is like, then probability of end of the sentence, given value is Henry. Okay, so I am going to find out for each cases, and then I am going to multiply together to find out the entire probability of the sentence. So what about for this case? So starting sentence 7 times. Okay, so how many times the word do occurs after starting sentence? 1, 2, 3. So it is 3. Okay, similarly, how many times do the word do occurs? 4 times. Okay, so how many times the word I occurs after do in the given corpus? 1, 2, 2 times. Okay, so it is 2 by 4. Next one, how many times the word I occurs? 6 times. Okay, so I am finding for this case. So how many times the word like occurs after I in the given corpus? 1, 2, 3. 3 times. Okay, it is 3 divided by 6. Then next one, how many times I am going to find out the probability for this case? How many times the word like occurs? It is 5 times. Okay, so how many times the word Henry occurs after like? Okay, so 1 time, 2 times. Okay, so I am writing here. I am going to find out for the last case. Henry how many times occurs? 5 times. So Henry word occurs for 5 times. After the word Henry occurs, how many times end of the sentence come? 1, 2, 3. 3 times. Okay, now you multiply this one. So it is 1 by 2. It is 1 by 2. That's all. 3 2s are 6. 6 3s are 18. 18 divided by, similarly, 5 5s are 25. 50, 100, 700. Some words. Okay. So if you compare this one, okay, this will give some better result. Okay, so based on that, we will say, okay, the probability of occurrence of first statement is higher than the probability of occurrence of the second statement. Okay, so I hope you will able to understand what are all the steps we can follow by using bigram model. Okay, now so 1 minute, I will connect the projector. Okay, so we have discussed about various types of models and how we can predict the next word using that particular models we have discussed. Okay, so once again I recollect, we have discussed about what is unigram, how we can predict the word using unigram we have discussed in the previous lecture series. So this lecture series we have discussed some practical problems using bigram, how we can predict the next word. Similarly, using trigram, how we can predict the next word. Similarly, using four-gram model, how we can predict the next word. This is what we have discussed. Okay. So now, okay. So up to this point, we have discussed till now. Now we are going to find, so what are all the basic challenges while we are using these language models, what are all the basic challenges the system is facing and how we are going to solve it using smoothing approaches. So this is what we are going to discuss now, and finally we are going to discuss what is perplexity. So this is what we are going to see now. Okay, so now we will see how we can evaluate this language model. So whether it is performing perfectly or not. Okay, so till now we have discussed about the concepts of language models. So using these language models, so how we can find out or how we can predict the next word occurrence perfectly. This is what we have discussed. Using bigram model, using trigram model, using four-gram model we have discussed. Now we are going to see in any model, okay, so we can say whether it is finding perfectly or not. So how we have to say that we have to evaluate that particular model. Okay, so here the language model evaluation can take place in two ways. So one is using extrinsic evaluation, next one is using intrinsic evaluation. Okay, two ways the evaluation will happen in language model to say that whether the language model performance is good or not. Okay, one is extrinsic evaluation, next one is intrinsic evaluation. So what is extrinsic evaluation? So it evaluates the language model while it is doing some specific task. For example, okay, so I am finding the speech recognition accuracy. So in that case, it will evaluate and it will say that whether that particular model is performing perfectly as expected or not. Okay, but the major disadvantage or major drawback is it is highly expensive and it is very time consuming. Okay, so these are all two major drawbacks or disadvantages while going for extrinsic evaluation. The another case is the intrinsic evaluation. So the language model will be predicted or will be evaluated when it predicts an unseen test set. Okay, so in that case only how we are doing, we are going to find out the perplexity level. So from the perplexity level, if the perplexity value is lesser, we are saying that particular model is better. If the perplexity value is higher, we are going to say that particular model, the complexity will be very more. Okay, so this is the point of why we are going for finding the perplexity term here. Okay. The major advantage of going for intrinsic evaluation, it is easy to understand and very easy to implement, and it can be easily converted to any gram. Okay, these are all major advantages. But what are all the disadvantages while going for intrinsic evaluation? So one major disadvantage is sometimes we will face underflow due to multiplication of probabilities. For example, so previously we have seen one example, right? Okay, so we have checked the probability of occurrence of I like sometime college, I think so, like college, end of the sentence. Okay, so while I am finding the probability of occurrence of the sentence I like college in the corpus. How I have find it out? I have split these sequences using the chain rule. So out of which I have got some, for example, I am writing some 4 terms. Okay, so these are all the 4 probabilities or 4 terms. So out of which I am checking, okay, the occurrence of the individual words. Then we are multiplying together and we are saying the probability of occurrence of the entire sentence. Okay, so here if you check, so 4 different probabilities we have checked for the individual words. So after that we multiplied all these things. Now for example, okay, so 3 of the probabilities are coming, but one probability it becomes 0. So what is the end result? Even though other probabilities are higher, but the end result will be 0. Okay, so this is one of the major drawback while we are using the multiplication in this particular scenario. Okay, that's what here it is written. So underflow due to multiplication of probabilities. So how I can solve this problem? Because our intention is to predict the number of occurrence of the sentence. Here this word is projecting higher. Okay, so similarly this word is also projecting higher, but because of one term the entire probability becomes 0. It is not correct. How to solve this? So in that case, so instead of taking the multiplication, we can take log of the values and then we will sum all the values. This is one way of smoothing approach. Okay, so one way of smoothing approach, log of 1. Okay, so now if you see, the entire result will not be 0, right? Even though if one value we are getting 0, that will not affect the other values. Okay, so this is one of the method. Okay, in order to avoid the 0 occurrence in the result. Okay, I hope you understood, right? So here the main drawback while you are using language model is sometimes because of one probability, individual probability occurrence, the entire probability will become 0, or we are calling it as underflow. Okay, so how to solve these kind of scenarios? Instead of going for normal multiplication, we can take the log and we can add the probabilities. This will avoid such scenario. Okay, this we are calling it as 0 probability problem. This is one way of doing it. Okay, taking log and adding the probabilities. What is the other effectively we can solve this problem is we can go for Laplace smoothing. Okay, so what is the other way we can solve this kind of problems? We can go for Laplace smoothing. What is Laplace smoothing? Okay, this is the given corpus we already discussed. From that corpus, I have written the words, individual words and its corresponding frequency of occurrence. This we have already discussed. Now, the main problem is the 0 occurrence. Okay, so how to overcome this problem? Okay, so how I can overcome the 0 occurrence problem using Laplace smoothing? Okay, so here leave the starting of sentence. Okay, here leave the starting of sentence. Okay, because it occurs only one time. Okay, apart from the starting of sentence, what are all the how many unique words are present in the given corpus? So how many unique words are present? 1, 2, 3, 4, 5, 6, 7. 7 unique words are present. Keep it. Okay. Now, what we are doing here, 1 minute. So So here 0 by 7, 2 by 3, some 2 by 5 into 1 by 2, like that. Okay. So 4 probability is there. Because of one value, the entire result will become 0. This is called zero occurrence. Okay. Now I am going to solve this kind of scenario or this kind of problem using Laplace smoothing. How we have to do? So in the numerator part, I will add 1 in all the individual probabilities into, similarly 2 plus 1 divided by, into 2 plus 1 divided by, into final case 1 plus 1 divided by. Denominator, what we have to do? So already 7 comes for the individual word. You have to add it with the unique words. How many unique words comes? 7. Okay, similarly every case 3 plus 7, 5 plus. So likewise. Okay. So now if you do, okay, now in the numerator the 0 disappears. It becomes 1. Okay. This kind of method we are calling it as Laplace smoothing. Okay. So this is what it reflected here. Okay. The same sentence what we have discussed previously. Okay. So like college. Okay. So here the first term it becomes 0. So after like there is no starting of sentence. So it absolutely becomes 0. Okay. So in order to avoid this 0 occurrence, we are going for Laplace smoothing. Okay. So how we are going for Laplace smoothing? We are adding the numerator by 1 and we are adding the denominator by number of unique words present in the given corpus. Okay. That is 7 unique words are present. What is that? We have seen in the example. Okay. So leave the starting sentence and number it 1, 2, 3, 4, 5, 6, 7. 7 unique words are present in the given corpus. So fill it in the denominator. Okay. Now if you check the result, okay. So the 0 occurrence will be eliminated. Now if you check, compare these two sentences, this sentence has the highest probability of occurrence while compared to this one. Previously what happened? Because of the problem of 0 occurrence or underflow, the result becomes 0. Okay, even though this probability is higher. Okay, this 0 occurrence problem will be solved by either going for taking log and adding the probabilities, or the best way is going for Laplace smoothing approach. Okay. Next one. Now we will find out perplexity. What is meant by perplexity? Okay. So what is the definition for perplexity? So it is the inverse probability of the test data which is normalized by the number of words. What it means? We are already calculating the probability of occurrence of words. This formula, I hope you remember. This is the general formula written for language model. Okay. So if it is 2 gram model, here it will become 2. Okay. W of 5, that means W of 1, W of 1 and W of 2. It will stop with here for bigram model. If you are using trigram model, here it will write 3. Okay. So here will be write 3. Okay. Similarly, that is 1. It will go on. Okay. So I minus 1, it will go like that. Okay. So this is the general formula for finding the language model. So now I am taking the inverse operation, because what is the definition for perplexity? It is the inverse probability of the given data. Okay. So here, if you want to find out the probability of this particular case, okay, take the inverse of this particular one. Okay. And how many terms are there? Individual probabilities are there? 4. So take 1 by 4. Okay, that gives the particular result. So that's what it has mentioned, 1 by n. Okay. So if there are 4 terms, give it here 4. that gives the value of perplexity. Okay, so I hope you understood. So here the concept is, if the value of perplexity is lower, it will be considered as the better model. If the value of perplexity is more, okay, there is so much confusion will occur in terms while predicting that particular word. This is one of the example given of WSJ corpus. It has training of 38 million words and test it with 1.5 million words. Okay, while using the unigram model, the perplexity value is 962. While using the bigram model, the perplexity value is 170. And when we are going with trigram model, the perplexity value is 109. What it means? Okay, so trigram gives the better result. This is what we can conclude in this particular corpus. Okay, so while we are dealing with the various language models, trigram gives the better result. After trigram, bigram model gives the better result because the value is 170. But when you check with unigram model, it is 962. It is not that much good model. Okay, that is the meaning of this particular case. So once again I repeat, if the perplexity value is lesser, we can say such model is the better model for prediction of word. Okay, so if the perplexity value is more, there is more lead to confusion or complexity in predicting the given word. Okay, so this is the meaning of that. Okay, so here, okay, so this is the example how we have find out the perplexity. As I already told, okay, so 4 individual probability is there. Okay, so after finding that one, it is 0.13. Take the inverse 1 by 0.13 and you have given 4 times inverse. Okay, so it will given the perplexity term. So okay. So now we will see the other smoothing approaches as well, so that you will understand better. Okay. So we have discussed about, in this session, we have discussed about, so how we can predict the word using bigram model, how we can predict the model using trigram model as well as 4gram model. Then we have discussed about, while using this model, what is the major challenges we are facing. One major challenge is the zero occurrence. Now how to solve that zero occurrence? For that purpose, we are going the concept of smoothing approaches. Okay, so first we have discussed how we can solve the zero occurrence or underflow using, okay, using adding log and adding the probabilities. That is one way. Or other ways, the zero occurrence problem can be solved by using Laplace smoothing. We have discussed what is meant by Laplace smoothing. Okay, so that means adding 1 to the numerator, adding the number of unique words to the denominator of each probability term. This is what we have discussed. Okay, so Laplace, we are also calling it as add 1 smoothing. Okay, this is what we have discussed so far. Okay, so here each probability, okay, so we are going to add 1 in the numerator and we are going to add the unique words in the denominator. So that is the concept of Laplace smoothing approach. Okay, this is we have discussed. The next approach is the add k smoothing. That means instead of adding 1, we are going to add some value called k. Okay, so instead of adding 1 in the numerator, we are going to add the value k. Similarly, instead of going to add directly the value v unique words, we are going to add k of v. Okay, what will be k? It will be small fractional values, 0.5, 0.05, 0.01. Some fractional values we are going to add in the place of k. Okay, this we are calling it as add k smoothing approach. Okay, next one is back off and interpolation method. So what is mean by back off method? So 1 minute. So what is mean by back off method? Suppose, okay, so we are trying to compute P of Wn, W of n minus 2 into W of n minus 1. What is means which method? We are using 2-gram model. Okay, sorry, 1 minute. So we are using, okay, two previous words. So which model this is? Trigram model. In 3-gram model only, we will use two previous words. Okay, so this is the formula, or this is the mathematical notation for trigram model. That what is means? Probability of occurrence of word n if word n minus 2 and word n minus 1 is given. Two previous words are taken into account in trigram model. Okay, so we are trying to compute using trigram model. Okay, but the given corpus, there are no such examples of particular. How many words we have to take? Previous words, 2 words we have to take, right? Within 2 words we have to compare the present sequence. Okay, but we are not having so much examples in that case, in the given corpus. In that case, what we have to do? We have to go for the previous step. That means from the trigram model, we are going to check for the bigram model. What is bigram model? So instead of taking two previous words history, we will take one previous word history. Now we will check whether we are able to find out the probability of occurrence of the next word. Still we are unable to do that case. Okay, so if we don't have enough counts to compute that particular case, we will go for the previous one. What is previous one? Unigram. So that step we are calling it as back off. I hope you understood. Okay, so we have seen some examples, right? So we have seen first given corpus, some 7 sentences were given. From the 7 sentences we have checked the various possibilities. Now some scenarios, okay, so I am using trigram model. So trigram model means how many previous words we have to use? 2 previous words we have to use. After the sequence of these 2 words, I am going to check for the given word probability, occurrence, how many times it is going to occur. Okay, but there are no several examples to find out in trigram model. Then what we have to go? Immediately we have to go for the previous case. What is previous model? That is 2-gram model. Okay, one step previous one. In 2-gram model also we are not having the enough counts to compute that case. We have to go for the previous step, that is unigram model. That step we are calling it as back off. Now what is interpolation? Interpolation is, so I am going to find the mix of probabilities. I am going to find using trigram, and I am going to find using bigram, as well as I am going to find using unigram. Okay, so this is what interpolation. By contrast, in interpolation, while compared to bigram, back off, okay, what is back off condition? If you are, while we are using trigram model, if you are not having the enough examples to compute, we will immediately go to the previous one, that is bigram. In bigram, if you are not able to find properly, we will go for the previous one, that is unigram, that is back off step. Okay, what is interpolation? We always mix the probability estimates from all the n-gram estimators. Okay, that means combining trigram, bigram, unigram, and we will find out the best case. Okay, so this is the operation of interpolation. Okay, what is this? I am going to find using trigram. Okay, so how I am saying this one? I am going to use trigram because, okay, so this is the word I am going to find out probability of occurrence of given word W of n if 2 previous words are used. Okay, what is the concept? This is the concept for trigram. So if I am using the simple linear interpolation method, what I have to do? I am going to mix all the cases. So this is trigram, this is for bigram, this is for unigram, and I am going to add all the cases. And the condition is, okay, while adding all these cases, okay, the maximum it has to come as 1. This is called linear interpolation method. Okay, this is one of the way we can able to compute the occurrence of the models or previous words. Okay, next one, there is another one method, that is Neisser-Ney smoothing. So this is also one of the popular model, okay, to find out smoothing methods. Okay, so it will also perform very well. Okay, so smoothing approaches we have discussed. One is how to overcome the zero occurrence. Okay, this is we have discussed using taking log and then add all the probabilities. This is one case. Or otherwise we can go for Laplace smoothing. It is also called as add one smoothing. Next we have discussed about add k smoothing. So instead of adding 1 in the numerator, we are going to add some fractional values. Okay, that is k value in the numerator. Okay, this is called concept of add k smoothing. And then we have discussed about the concept of backoff and interpolation method. Okay, these are all the cases we have discussed in the smoothing approaches. Okay. So finally, I will summarize what we have discussed in this particular session. So in this particular session, first we started recollecting the concepts we have discussed in the previous session. Okay, previous lecture video we have discussed about what is language model, what are all the applications we are using the language model, and then we have discussed about what is unigram model, what is bigram model, what is trigram model, what is fourgram model. So what are all the mathematical formulas behind it? So all these things we have discussed in the previous lecture. This lecture we have discussed about using practical problems, how we can understand the concept of bigram, trigram and fourgram methods. Then we have also discussed about, okay, so if some multiple sentences are given, so which sentence has the highest probability of occurrence out of all the given sentences? Using bigram or trigram or fourgram we have discussed. Then we have discussed about, while using these language models, so what are all the major drawbacks we are facing or major challenges we are facing? One of the major challenges is zero occurrence or underflow error. How to solve these kind of problems? So for that purpose only we are going for smoothing approaches. We have discussed about Laplace smoothing, then we have discussed about add k smoothing, then we have discussed about the concept of backoff as well as interpolation. Finally, we also discussed about Neisser-Ney smoothing approaches. Okay. Finally, we have also discussed about how we can evaluate the language model. So there are two ways of we can do the evaluation. One is extrinsic evaluation, next one is intrinsic evaluation, and then, okay, so we have also discussed about what is perplexity. So if the perplexity value is lower, such model we are calling it as better model. If the perplexity value is higher, that leads to lot of complexity or confusion. This is also we have discussed so far. Okay, so these are all the various topics we have discussed in this particular lecture series. So next lecture series, next video lecture, we are going to discuss about hidden Markov model and how it will be used in the case of randomness. Okay, we will see in the next video lecture. Thank you so much.